Okay, this is the...
Hello, ladies and gentlemen. I'm Dr. Sferanos, and I am privileged to work with Dr. Shin, who is our official photographer. Basically, today we're going to do qualitative tests for alcohols. And the first test we're going to be doing is called the Jones test, where we will test whether we have a primary, secondary, or tertiary alcohol. A primary alcohol is an alcohol that has a carbon and only one carbon attached to the carbon carrying the OH. The secondary one is an alcohol that has a carbon that has two carbons attached to the OH, to the carbon that carries the OH, and then a tertiary alcohol is an alcohol that has three carbons attached to the carbon carrying the OH. The Jones test is an oxidation of alcohols test. And what we use here is chromium plus 6, which will become chromium plus 3. Chromium plus 6 is orange. Chromium plus 3 solution is green. Okay? So, what is going to happen now is you are going to test these alcohols. When you oxidize an alcohol, there are basically what you do is you lose two hydrogens and you get a carbonyl. Now, if chromium plus 6 becomes chromium plus 3, therefore this one, chromium plus 6, gets reduced. Remember, you have 6 and you go down to 3, so it gets reduced. If it itself gets reduced, this means it oxidizes someone else. This is the active voice versus a passive voice. So chromium plus 6 gets reduced, therefore it is an oxidizing agent. So the alcohol now will get oxidized and you lose the H and OH here, so you finish up with an aldehyde first, which will get further oxidized to give you the corresponding acid. In the secondary one again, you lose a hydrogen and a hydrogen, so therefore you have an R, Cr, C double bond O with an oxygen. And if you cannot further oxidize, so you stay where you are. And the tertiary alcohol, there is no H attached to the carbon that carries the OH, so therefore there will be no reaction. Which means, if you react a primary alcohol, you will definitely see a change from orange to green, of chromium plus 6. If you have a secondary alcohol, you definitely see a change from orange to green. If you have a tertiary alcohol, there should be no reaction and the orange will persist. This is, believe it or not, this is the reaction that takes place, at least in the old times, when the police was stopping you on Friday nights or Saturday nights and asked you to take the breathalyzer test because you were driving in a funny way, which is a mistake, of course, because you're supposed to be home and doing homework. And so therefore what happens is the policeman would ask you, have you been drinking? And of course you cannot play wise guy and say, oh, yeah, I was drinking a primary alcohol, because then the policeman is going to get upset. But on a serious note here, some people always ask me, why don't we make alcoholic beverages using a tertiary alcohol? Well, in this case what happens is, if you drink tertiary alcohol instead of ethanol, what is going to happen to you is that you will end up in a cooler, most likely in the basement of a hospital. So therefore, you're better off drinking ethanol. Not that I promote it. But on a serious note here, what you're going to be doing this test four different times. Once with the primary alcohol, once with the secondary alcohol, once with the tertiary alcohol that we know they are primary, secondary, and tertiary respectively. And then we will have an unknown and try to compare. So here we have a primary alcohol, okay, and we have a secondary alcohol, and we have a tertiary alcohol. And what we're going to be using is, we will use sodium dichromate, which is, as you see now, when I put it here, you will see an orange solution. And we will do that 4 times. Once for a primary alcohol, that is known primary alcohol. Once for a secondary alcohol, and once for a tertiary alcohol. And then we will do that also for the unknown and compare. So here we go. Here it is the dichromate solution. And what we have here is the 4 test tubes. The first one says primary, you see that here, primary. You see that here, secondary. You see that here, tertiary. And then you see here, number 4, which is the unknown U. Now what we're going to do now is you're going to add a little bit of sulfuric acid. See sulfuric acid here? And we will add a few drops. To each one of them. And now what we have here is a solution of dichromate and acid, which behaves as a catalyst. And you see the solution is orange, right? Everybody agrees? Okay. Now what we're going to do now is we're going to take a primary alcohol and we will add a few drops of that. And you see here the color change into green. Do we see that? Okay, great. Now what we can do is we are going to have the secondary alcohol and we add it here. And again, it's a little bit slower. And as you see, slowly changes, slowly changes, slowly changes. You have to shake it up, shake it up, shake it up. And you see now the color also changes to greenish blue. Okay, so far so good? Okay, now we're gonna do the tertiary alcohol. Add the tertiary alcohol here, and obviously there is no reaction as you see. So you see the primary one gives you a bluish green color. The other one is bluish green color, and the tertiary one doesn't do anything, right? Now, so now we pick up an unknown. So let's pick up unknown number 5, lucky 5. And what we have here is we will add this and add it here and see what happens. Shake it up, shake it up, shake it up, shake it up, shake it up. Oh my goodness. Okay, so what does this show? This shows that this is either a primary or a secondary alcohol. Are we in agreement? Now, for those people who are more advanced in chemistry, usually the primary one gives more of a bluish color. The second one gives more of a greenish color. So this one, I am tempted to think that it probably is a primary alcohol. But again, you can't decide for sure that it's primary, secondary, or tertiary alcohol. Did I mess you up? So far, so good? Any questions, please? So that takes care of the Jones test. Are we in agreement here? Do we see that? Okay, so from your left to your right. The first one is a primary alcohol, and secondary one is here. Tertiary one has no reaction, the unknown has. So this means my unknown is either a primary or a secondary alcohol. Are we in agreement? Any questions? Okay. It's going to be called Lucas test. And the Lucas test, what happens is if you have an alcohol and you treat it with HCl and zinc chloride as a catalyst, you end up with RCl plus water. This one is insoluble. So contrary to what we learned in general chemistry, all chlorides in organic chemistry are water insoluble. In inorganic chemistry, they are soluble because we do have actually ionization taking place, but there is no ionization in here. So the situation is that tertiary ones react much faster than secondary, which react much faster than primary, which react much faster than methanol. So this is reactivity reduced, going from left to right. And in the tertiary situation, you see two layers immediately, the secondary one, you see two layers after 5 minutes. And here these two react very slowly. So basically, no reaction. So again, the tertiary one immediately reacts, the secondary one reacts after 5 minutes, the primary one reacts very, very slowly. And of course, for those people who take more advanced organic, this is because the tertiary carbocation that is formed much easier because it's much less unstable than the primary one. And so therefore, the tertiary will react much faster. So what we're going to be doing now, we're going to be doing the same test again, same way we did before, which means we're going to have the primary, we're going to have the secondary, we're going to have the tertiary, known in 3 different test tubes, and we will do the test with the Lucas reagent, which is HCl zinc chloride, and we will test them, and we will have side by side also the unknown. Any questions at this stage? Great. So first of all, we are going to have the Lucas reagent, which is this one. And what we're going to be doing is we're going to be adding the Lucas reagent in all test tubes. And this is our unknown, number 4. Now, for those people who remember a little bit of general chemistry, if your test tube happens to be wet because you washed it just before you did the experiment, what is going to happen is that the reaction, because water is a product, the reaction will be reversed, and the results and the timing will be messed up. So therefore, whenever we do the experiment, we always make sure the test tubes are absolutely dry, so the reaction is pushed all the way to the right-hand side the way we want. Okay, so what we're going to do now is the following. We're going to be using the primary alcohol. We add it here. We have the secondary alcohol. We add it here. And we have the tertiary alcohol. Add it here. You see the tertiary alcohol immediately reacted with in no time? Do we see that? And you see the 2 layers, right? One layer is water layer, the other one is the alkyl halide layer. And so therefore the tertiary one reacted a little bit slow. Primary and secondary ones are still slow. Sorry, the tertiary reacts very fast. Primary and secondary are a little bit slow. Okay? So we'll have to wait a little bit for the reaction to take place. In the meantime, I'm going to do the unknown. And the unknown is here, number 5, as we said. Okay, so we will add number 5 here, 2 in here, and we notice that the reaction still obviously is not tertiary, but you see there is a situation, again, we have to wait a little bit for this to take place, and while we're waiting for this to take place, we will do the iodoform test. Okay, you can heat it up. So this is the secondary, this is the primary, this is a tertiary, the unknown, I'm sorry. The tertiary we know it reacted immediately, no problem with that. So we heat it up a little bit. Okay, so you see after a little bit you see the secondary reacted, you see 2 layers? Okay, remember the tertiary reacted immediately, this one needs a little bit of heating, we have to push it a little bit harder, okay? The primary one didn't react at all, sorry. The primary one didn't react at all, and again, as we see here, the this looks more likely a secondary alcohol. Do we see that? Because it matches more or less this one. So this is a secondary, so our no most likely is a secondary alcohol. Okay? So here we go again, we show this is the primary one, no reaction. The secondary one reacted a little bit slower than the tertiary one, and to beef it up, what we had to do is heat it up a little bit longer. The second one also, the unknown, I'm sorry, seemed to be like a secondary one because with a little bit of heating, the reaction took place. Okay. The third test we're going to be doing is called the iodoform test. The iodoform test, what actually takes place, it's characteristic for alcohols that have this group. What happens now is if you treat this one with I2, Ki, and base, you end up with CH3, plus COH, double bond O, and the carboxylic acid. This is a yellow precipitate. Very easily interpreted if we have an alcohol of this type. So my question to you is the following. How many primary tertiary alcohols will give positive iodoform test? So again, yellow precipitate means positive test. Okay, so we have a tertiary alcohol. You have a carbon here, so there's no way a tertiary alcohol will give you a positive iodoform. Why? Because you have a hydrogen here. So if you have a hydrogen here, it can be either ethanol or it can be a secondary alcohol. But tertiary alcohol cannot have a hydrogen attached to a carbon that carries the OH. We discussed that earlier. If you have primary alcohol, the only one is ethanol. Because if you have a hydrogen here, it's okay, because what we need here is this group. If we don't have this group, the reaction does not take place. No. Secondary alcohol, we have many. Is it all secondary alcohols? No. Only alcohols that have CH3, CHOH. So for instance, if I have CH3, CH2, CHOH, CH2, CH3, versus CH3, CHOH, CH2, CH2, CH3. This one will give positive test. Why? Because you have the group here. This one will give you negative test. Why? Because you do not, you see what you have here is CH3, CH2. You don't have CH3 directly attached to the carbon that carries the OH. So, how many secondary alcohols do we have? Many. What is the condition? Only ones that have the formula of CH3, COH, H, and R. If you do not have a CH3 directly attached to the carbon that carries the OH, the reaction will not take place. Are we in agreement? So let's go over it again. For the reaction, we need to have a CH3 attached to a carbon that carries the hydrogen and OH. This one we will treat it with iodine, Ki, and OH minus to give you CHI3 and the corresponding carboxylic acid. We have primary, secondary, and tertiary alcohol. Tertiary alcohols will never give you a positive iodoform. Why? Because tertiary alcohols do not have a hydrogen attached directly to the carbon. Primary alcohols, there is only one, and this is the one that has a hydrogen here, so it's ethanol. Secondary alcohols, there are many. How many? We don't know. There can be an infinite number, but not all of them. Why? Because we need to have this formula, which means CH3, carbon OH, H. Now, if you are planning to do the experiment in the lab, you have to make sure that your test tube is absolutely clean. You cannot wash it with acetone. You cannot wash it with isopropyl alcohol because it will give you a positive iodoform. And that's not what we like to have. What we like to have is a situation where you have a pure alcohol. Acetone also gives you a positive iodoform for another reason. That we do it twice. We're not going to do it on primary, secondary, tertiary alcohol and unknown like we did with the Lucas and the Jones. We're going to do that only on two compounds. One of them is our unknown, and another one, which is number 5 here, and another one which is known as positive iodoform. Okay? So what do we need to do in this case? We will use potassium iodide, okay, and we will use the same potassium iodide. Okay, and now we're going to add a few drops of sodium hydroxide. So we have the sodium hydroxide here added. Okay, maybe we need to add a little bit more iodine here. Now remember now, what our aim is to get not a yellow solution, but a yellow precipitate. Okay, so what we're going to do now is we're going to take So now here we go, we have the two solutions. Yes, one of them is a little bit more darker than the other one, but that's all right. Our aim is not to get the solution red or yellow. Our aim is to make sure the solution actually creates a precipitate. So first of all, we will work it out with a compound that is called positive iodoform. So we add a little bit of the compound here, and here we go. Okay, now if you heat it up, it will give you a yellow precipitate. So I'm just leaving it in the oven for a while. And then what I can do is I take the unknown and I add it here. And I keep on shaking it up. And you see over here, the unknown doesn't seem to be giving you a precipitate. Now over here, you see the solution becoming cloudy. In the long run, when you heat it up for a while, you can add a little bit of hot water here if you like. Okay, and what happens here is the solution stays intact here, but over here you get the precipitate, and if you centrifuge it, you will find out that this is actually a positive iodoform and it will yield the yellow precipitate. So again, this is our known and this is our unknown. This means our unknown now does not have this group, CH3, CH-252. So what are we supposed to do? What I would like you to do first is you go to your lab manual, and I think the page is 273, and you have a list of possibilities. The very first thing you do is you fill in that table with the structures. Okay, and classify those alcohols that you see over there as primary, secondary, or tertiary. Then, what you do then is the following. Check your unknown what it is. In our situation, we said our unknown is either primary or secondary, cannot be tertiary. Remember, we said that the Jones test was, for the unknown was negative, right? It was positive, therefore it was not a tertiary alcohol. When we did the Lucas test, we said most likely we have a secondary alcohol, and because we showed the two test tubes that the unknown alcohol, and the where is that? Here's the secondary one, and here's the known. Basically, they gave you these two layers after a little bit of heating or 5 minutes. And so therefore, most likely our solution is, or known happens to be a secondary one. And then we did the Iodoform test, and in the Iodoform test we showed that definitely we knew it was not tertiary, and we proved it. What we can do here then is that over here, as you see, this is a positive. You see a little bit of a cloudiness. If you centrifuge this one, you will see a yellow precipitate coming out. And this means my unknown is not an alcohol that has this group CH3CHOH. So based on your conclusions, your job is to describe in your report what you actually did, and then decide by choice from your table whether it's a primary, secondary, or tertiary alcohol. Now, there is a possibility that more than one compound matches the number 5 unknown results. It doesn't really matter, but you can say for sure, you can exclude the fact that we know it is not a tertiary one, that most likely it's a secondary one, and most likely it's a secondary one that does not have the CH3CHOH. So if you have any questions, go ahead. Please do not forget to provide a report with your conclusions, and then we will work around with this. Any questions that you may have? Okay, thank you, and please a loud applause to Dr. Shin for being a grand photographer. Thank you.